I'd like to welcome everybody to the first of many webinars hosted by the Product Quality Cleaning Workshop. We're going to be hosting webinars with our sponsors, but also with the instructors, Barbara and Ed Koenigsberg, discussing things from my cleaning research group and also some of the students who've been doing research in the cleaning research group. And so welcome. For some housekeeping first, let's look at the Q&A button you see down at the bottom of your screen. Don't worry about this being live and recorded because you're in audience mode, but you can ask your questions to the panelists using the Q&A button at the bottom of your screen. We will answer a few of these questions at the end of the seminar, but the bulk of the questions will probably be answered by email, as is typical with these events. You will receive a PDF of the slides at the end and a link to the recorded webinar in a follow-up email. So let's begin. Here's the panel for today's webinar. The PQCW team consists of myself at Sam Houston State University in Huntsville, Texas, and Barbara and Ed Koenigsberg of BFK Solutions in California. And we are excited to have Michael Onken and Christian Riesner to join us in this webinar from SAFECHEM. Michael has degrees in chemistry and business and is also the manager of their product development. And then Dr. Riesner is the leader of SAFECHEM's R&D department. I'm Darren Williams, professor of chemistry at Sam Houston State University and leader of the cleaning research group and the co-chair of the product quality cleaning workshop. My partners in this are Barbara and Ed Koenigsberg, who wrote the book on critical cleaning, as you can see here, the CRC Handbook for Critical Cleaning. They are independent consultants and have been helping the industry in cleaning and their process improvement for many, many years. One other thing that you'll hear us talking about is this PQCW. What is that? So Barbara, why don't you tell us a little bit about the PQCW?
Absolutely. Thank you, Darren. PQCW stands for Product Quality Cleaning Workshops. Were it not the pandemic, a number of us would have been down at Sam Houston State having a hands-on workshop, complete with going right into the lab, testing, actually doing the cleaning, seeing demonstrations. So it's a wonderful combination. Given the situation right now, we're in webinar mode, and that's another great way for you all to learn. The idea of PQCW is to develop resources for more effective cleaning processes. You know, all of us have both the academic background and the technical experience, the street smarts as well. So this is where it's a great resource for you in industry. Where can you get more information? Well, in two places. One on the Sam Houston State Educational Resource at PQCW. The other is at BFK Solutions under Manufacturing Minds PQCW. And of course, you'll have the link. We do look forward to doing these live, also to working with you on more webinars.
Yes, thank you. We're doing these webinars, which is a nice chance to kind of get the inside scoop on cleaning. And so that's why I'm glad to have Michael and Christian here from SAFECHEM. So Michael, tell us something about SAFECHEM and how you fit into the cleaning industry.
Thank you, Darren, Barbara, and Ed for welcoming us here. So SAFECHEM is the service company responsible for the safe and innovative use of chemicals. What does this mean? We've been founded already in 1992 by the Dow Chemical Company as a service division taking care of the safe use of chemicals in the industrial parts cleaning segment. That's what we are doing still today. So what you see here on the picture, on the left hand, at the bottom on the left hand side, that's our SAFECHEM system. That's a double-walled safety system in which we, among other packaging, are supplying chemicals. Systems can then be directly connected to the clean machine, and the operator then has no contact with the chemical anymore. So what we're doing is risk management, making then with these systems, let's say, storage, transport, and handling of chemicals possible.
Michael, you also help customers with process development and product support. Can you give us some detail about that?
Yeah, that's right, Ed. So what you can also see here is in the middle, it's a test kit. It's a test kit we are supplying customers. They can then check the solvent status on site. They can check the solvent status, and in case the solvent is not in good condition anymore, they can use our stabilizers to bring the solvent back in good condition. So what we're doing here then is process optimization, and we are reducing dramatically the consumption of the solvents. What we're also offering are lab analyzers, which you can also see here on the slide. These are solvent analyzers to really have a deep look into the solvent, into the chemical, and also offering all compatibility tests to make sure that the contaminations the customer is cleaning off from the parts is compatible with the solvent. So what we're doing then is risk management and optimizing processes at our customers to make the use of solvents more efficient.
That's really important from a performance, a cost, and an environmental standpoint. It hits that hits all the points. So, Michael, there are at least 500,482,282.5 cleaning agents on the market, aren't there? That was what I had at last count. Can you give us some perspective as to how the SAFECHEM cleaning agents fit into the world of cleaning chemistries, please?
Yeah, sure. So what we're focusing on today are modified alcohols, and to understand how modified alcohols can help customers, it's important to understand the concept of polarity. What we have here on the picture is water in a glass, and we put some oil into it. I also have it here in this tube.
Ooh, a live demonstration, is it? Yes.
It's like salad dressing to me.
Yeah, it is. So, green chemistry. You can see that both substances, the water and the oil, do not mix into each other. Also, when I shake it now, it will take a moment, but you can see that it separates again. So that's why, the reason for this is that the oil is non-polar and the water is polar. So they are chemically very different from each other, so they do not solve into each other, and that's why they separate. So now you can really see also in the live demonstration that they separated again. Yeah, the question is, what does this mean for industrial parts cleaning? So when you've got a contamination on the part, which is, let's say, non-polar, and you use a polar cleaning agent, then the contamination does not solve in the cleaning agent and may stay on the part. And also the other way around, when you have a polar contamination and use a non-polar cleaning agent, they also do not solve into each other and then stay on the part. So that's why it's very important to understand the concept of polarity when we talk about cleaning agents. And on this slide, I've sorted for you the contaminations and also the cleaning agents by polarity. So on the left-hand side, you've got the non-polar contaminations at the bottom, like oil, waxes, petroleum, for example. And on the right-hand side, you've got polar contaminations, like salts and emulsions. The question then is, which contamination should I clean with which cleaning agent? And when we start at the top, you see that there are hydrocarbons. Hydrocarbons are completely non-polar. So hydrocarbons are very good to clean non-polar contaminations. Also, chlorinated solvents and halogenated solvents, they are also non-polar, therefore very good for non-polar contaminations. And on the right-hand side, you've got water. Water, as we already discussed, is polar, therefore very good to clean polar contaminations from the parts. You can also add surfactants to water and builder substances to extend the application range. But then you also have to add additional chemicals to the water. When you've got a lot of non-polar contaminations you're cleaning off, then it may become not an efficient process. Then we come to the modified alcohol range. And modified alcohols, they are kind of hybrid molecules. So they've got a non-polar part and a polar part in one molecule. So that means these products are able to clean both kinds of contaminations. And that's what you see here on the screen. So you see the modified alcohols, which are more in the middle. The reason for this is also that customers very often do not only have one kind of contamination on their parts. So they often got mixtures, it's oil, there are some emulsions on the parts, so they need a product with a broader application range. And this is exactly where modified alcohols come in. So with their molecule with the two functions, these products are able to clean both kind of contaminations. And there are different products available, like the Dowclean 1601, which is a product which is better for non-polar contaminations, but can also clean partially polar contaminations. Then we've got another modified alcohol, the Dowclean 1611, which is more polar, so better for polar contaminations. Dowclean 1621, which is less polar than Dowclean 1601. So you can really choose the modified alcohol depending on the contaminations you have. And with this, we have a broader application range and can clean more kind of contaminations with these modified alcohols.
This is Ed Koenigsberg, and I have a question for Christian. We're practical nerds over here at SHSU and BFK Solutions.
Yeah.
Alcohols may be new to many people. Help us understand and compare their properties to other familiar solvents like water, the perchloroethylene, and hydrocarbon solvents. And if you have a comparison to 1-bromopropane, NPP, and trans 1,2-dichloroethylene, that would be a plus.
Yeah, thanks for the question, first of all. And I can confirm that I'm more practically oriented and I'm not the biggest theoretical chemist in the world, obviously. And I really like to imagine the things. And here we have a very schematic drawing of a modified alcohol molecule. And actually the bifunctionality is in there. What we see here is that the modified alcohol is color-coded in the same way as oil, in the same non-polar-polar topic. So the polar parts of the modified alcohols are color-coded in blue, and the non-polar parts, or the little polar parts, they are color-coded in yellow. And we see a lot of yellow here, which is interacting with non-polar salts like oils, like fats, greases, which is shown on the left side here below. And there we have a hydroxy group, which is on the upper left side. And this is the same functionality which offers hydrogen bonding, such as alcohols and water. So here we have the advantage of a modified alcohol, which can as well interact with polar salts, as we see here on the right side. And compared to isoparaffins, they do not offer this blue functionality. They are just, if we would color code it in that way, they would just be yellow. N-propyl bromide, perchloroethylene are really in the same range and very little polar. So they are very good cleaning agent for non-polar contaminants, but less good than modified alcohols for polar contaminants. And this is just a simple scheme. And I know that there's much more meat on the bone if you look deeper in the numbers. There is one thing that I want to highlight is the Hansen solubility parameters. And actually, Darren is very experienced in that. And yeah, maybe you want to just say a few words on that.
Sure. I think that, we could go into quite a bit of detail with the hydrogen bonding we see here, the polarity and the dispersion. These three terms allow us to plot these solvents on a three-dimensional grid. And you can see here, without going into too much detail, the hydrocarbons are down here at the bottom. And then up here at the top is water. It's actually off scale on this plot. And the alcohols and the modified alcohols are right in between, allowing them to interact with the polar soils and the non-polar soils. And so you can learn all about this theory, the Hansen solubility parameters theory, and how solvents and soils interact at the workshop. Let's get back to the details about the modified alcohols, though, and look to see what kind of operating parameters that they have.
Okay, thanks. I would like to highlight that you don't only buy a solvent, you buy a solvent plus a machine. Yeah? Depending on the physical parameters, you need to think that the machine types are pretty much different. So I would like to highlight a few points, not going into detail again. You have the boiling temperature of Dowclean 1601, which is the example for modified alcohols, trichloroethylene as chlorinated hydrocarbons, as chlorinated hydrocarbon in aqueous cleaning. The boiling point of modified alcohols is higher than trichloroethylene and of water. So you might think that the energy needed to run a Dowclean 1601 machine is quite high. but eventually it's the difference. Yeah. So when looking at the heat of vaporization for Dowclean 1601, it is 280 joule per gram. But it's very comparable, pretty much comparable to trichloroethylene. So, and much less of that of water. So you need 8 to 10 times less energy to heat up and vaporize a solvent compared to water. So running a solvent machine, it's an energy saver. So this is important when it comes to machine technology. Another point is the flash. Another thing is the flash point. So Dowclean 1601 has a flash point, and it's within the operation conditions. It's below the boiling point. Trichloroethylene has more or less a theoretical flash point, which is much above the working condition, and water doesn't have any. So what does that mean for the cleaning technology? The working condition for Dowclean 1601 or other modified alcohols, or as well as isoparaffinic solvents, is that if you want to do vapor degreasing, you need to have a vapor, you need to have a vacuum machine, and the vapor of Dowclean 1601 or other modified alcohols is at a temperature of about 100 degrees C. For trichloroethylene, you could work in normal pressure, ambient pressure, and the vapor would be at 87 degrees C. But with regards to cleaning, this is a difference. Yeah. For water, you would typically operate in elevated temperatures, but not have boiling temperature, because this is just, in energy-wise, this is just not realistic.
Okay, so you answered a lot of my initial questions, and I think the lower heat of vaporization is important in terms of drying, very important. So I'm glad you pointed that out. Christian, I know you we brought along some pictures of the cleaning equipment or diagrams, so could we talk about that next, please?
Thanks. This is a technique that has been developed in over the last 20 years, and the closed machine, they are really fast in degreasing parts. So this is a typical drawing with 2 wash tanks, a cleaning chamber in the middle, a distillation unit or vapor generator at the right-hand side, and a condenser on the top. So typically, parts would enter the cleaning machines. Parts would enter the cleaning machine. A vacuum is applied of 100 millibar. Then parts are rinsed with the solvent from the flush tanks. And you can apply mechanical movement to assist the cleaning. You can apply ultrasonics, because that is as well helping to make the parts oil-free and free of contaminants. And then the final step is then the vapor degreasing, and this is actually bringing the final glance. So parts are more or less like 95% clean after the second rinse, but the vapor, the hot solvent vapor, is condensing on the colder parts, and this is ultra pure solvent, and it's just taking away the oil. Parts can come out fully clean, and this is actually very efficient. And this is from part of perspective of efficiency, of energy saving, this is very, very elaborated.
So that's a great demonstration. And I know that you have specified what people in the States, and especially in California, refer to as an airless enclosed system for the modified alcohol. But in terms of flammability, could other cleaning equipment be used? For example, you wouldn't want to use a standard open top degreaser, because that wouldn't work because of the flash point and probably the boiling point as well. But there are open top systems that are enclosed or sort of sealed for low flash point solvents, but operate at atmospheric pressure. They're not airless, so could they be used? How would you manage things there?
Yeah, so we have to keep in mind that these modified alcohols do have a flash point of 63 degrees Celsius or 145 degrees Fahrenheit. And we always recommend, when you're under atmospheric pressure, to have a safety buffer between the flash point and the ambient temperature. And this should be 15 degrees Celsius or around 60 degrees Fahrenheit. This limits then the operation temperature. The full experience of the modified alcohols you have in such a airless closed system, because you can run the system at high temperatures, you can clean at temperatures above the flash point, you do have vapor degreasing at the end, so for the really consistent cleaning results. And what's also very important in these systems, you've got a distillation unit built in, so vacuum distillation, and there are studies available about the removal of 220 pounds or 100 kilograms of oil from parts. And they investigated how much solvent you need to clean off this amount of oil. And when you've got an open machine, you need 1,642 pounds to clean off 220 pounds of oil. Why? When you've got an open system, most of the solvent goes into the atmosphere. It's not really used for the cleaning process. When you've got a closed machine, the consumption is already dramatically reduced to 343 pounds of solvent, which is required to clean off 220 pounds of oil. So that's already quite good. There are much less air emissions, but still a lot in the waste. And when we come to the airless closed system with the vacuum distillation, where then chemical product services are in place. So chemical product services is the solvent monitoring you can do on site with test kits. And then in case the solvent is not in good condition anymore, you can stabilize it to bring it back. It's what I already said at the beginning. And when you do this, such a closed system, the vacuum distillation, the consumption is dramatically reduced. You only need 33 pounds of solvent to clean off 220 pounds of oil. We've got customers who need less than 5 pounds per 220 pounds oil to be removed. So really efficient processes. And this is only possible then with these closed machines, solvent monitoring and stabilizers.
Yeah, that's pretty good. I tell my students as well too, because we redistill our solvents in the lab, and again, it makes perfect sense if you can reuse it, rather than lose it to the atmosphere. Let me also say that a longer discussion of this whole process is available. There was a webinar that was a team effort between Gardner, Hubbard Hall, and SAFECHEM, and it's available, and you'll receive a link to that webinar in the follow-up email as well. So there's also more information available from a slightly different perspective on that webinar too. Moving on, I have a question about soils and substrates. What kind of challenging soils and substrates have you looked at, Christian?
Yeah, Darren, the question is always, it comes back to the like dissolves like question. And I would like to show that again. Yeah, here we see oil and here we see water. So if you want to mix it, it just doesn't work out perfectly. Here you have drops of oil in the water and drops of water in the oil. So typically, if you apply aqueous cleaning, which is seen on the right-hand side, if you want to clean up oils and you have an aqueous cleaning machine, the risk is that you have kind of this greasy plate or the greasy part. Doesn't necessarily be metal or whatsoever, but this can come out because it just doesn't dissolve. If you have solvent cleaning, in contrast, you would most likely end up with a shiny surface if you have an oil cleaned off. Whereas if you have a polar contamination for aqueous cleaning, like salts or whatever, or if you do electroplating, then you would better be off with an aqueous cleaning machine, because with solvent cleaning you may end up with spots. And this might happen if the machine producer and the customer, or if the customer is changing the cleaning operation in the process. So typically, this question of cleaning results is mostly between the customer or the metalworking company and the cleaning machine producer, because they would send parts. The cleaning machine producer would put the parts into a demo machine, and then they would find out if the solvent or the aqueous cleaning machine is suitable to clean off the parts. Things like that occur, and then this is part of technical service, and this is what SAFECHEM offers to find a solution. I would just like to highlight another challenge, because we are talking a lot about cleaning results, but the second part is when it comes to process security or process efficiency. It's very, very important to keep the solvent as long in the machine, and that the machine has as little damages as possible. One challenging project for me and for Michael, because we're working together in that field, is the development of MaxiStab S series. So this stabilizer series has actually expanded the use of modified alcohols to very, very challenging substrates, such as chlorinated oils, because they can decompose to give hydrochloric acid, which is known for in chlorinated solvent cleaning. But you need to be careful, and with the help of these stabilizers, you can now make the modified alcohol cleaning much more secure than before.
That's very interesting. SAFECHEM does have an applications lab. What are the capabilities? Can you give us a quick tour or a description?
Yeah, we do have a lab. It's just right now I'm just still in the conference room. Maybe I can show you a little bit about the capabilities and show you some of the standard offering that we have. So Ed, you may imagine that you're working in a metalworking company and you just send over your parts to a cleaning machine producer, and they were successful, which is good, and you are about to purchase a cleaning machine. So you think, okay, cleaning results, they work fine, but what about the process lifetime? How many maintenance costs would I have over the year? How much solvent would I need to buy? Do I need to replace my bath? Or what is the process like? For that, we offer a unique testing method, which is the oil compatibility test. This is can be imagined, a photo is shown here on the right-hand side of the device, and it can be imagined like a laboratory scale cleaning machine. So solvent and oil is continuously heated up for 7 days, 24 hours. Actually, what we do is we distill the solvent, we take a sample from the distilled solvent, and we can observe if the process will last, how the process will develop. And we have a perfect model for over 1 week. If the process will be stable, if it will be stable in the beginning and then deteriorate, or how the important process parameters would look like. And this is well accepted all over Europe. And actually, this is really recommended because it is a perfect modeling of the process before it actually comes to the real world. Yeah. This is before starting the operation. And you may think that you now have your cleaning machine and you want to look at your solvent. So this is the second part. Solvent analysis is it's like the blood image of the solvent, and we can look into the details by gas chromatograph, GCMS, ion chromatography. We do water content measurements, pH measurement, titration, all of that methods. And we will have a deeper look into the solvent quality. And then we can say, hey, we can make tailor-made recommendations of how you can manage your solvent, or that your solvent is actually in a good shape. It is a little bit like going to the doctor. The stabilizers, the test kit is like a fever thermometer. You would apply it and measure your temperature. Then you have a pill, which is the stabilizer, which you would take if you have a headache. But you wouldn't like to take thousands of pills because your temperature is always too high. You just go to a doctor. And this is the solvent analysis. You would measure a lot of important parameters, and then we can have a deep view. If you can go on, if you would have to do some measures, and yeah, this is just recommended to do it regularly because preventive measures are always better than reactive. Well, you go to the doctor and sometimes they send you over to a specialist. If there is some kind of sludge, what you see on the right-hand side, which you don't know where it comes from, or if you would have, hopefully it doesn't never occur, but if you would have a corroded part, then we can look into that. Or if you want to have some evaluation, some really out of the box, then we can do it as well. We work with an accredited laboratory, and we are offering a high standard, and we can actually do whatever we play around. We do product development. So if you have any idea, just maybe we can work together and let us know. Yeah. So this is the lab tour.
That's a great tour and a nice socially distant and socially appropriate tour for these times. So I love the analogy about going to the doctor and running the tests, because I think I've discussed with you that Dow used to own a clinical lab back in the 70s, long time ago. I'm a child worker. I designed lab tests then, and indeed there are very, very much similarities between how healthy you are, how's the solvent doing, and how clean is clean enough. You also, in much earlier slide, which we don't have to switch back to, mentioned a number of different Dow cleans. There is one in the States right now that's mainly the alcohol, but can you tell us more about other specific SAFECHEM cleaning agents? Are they, I gather they're available in Europe. Can you get them in Texas, in California, in New Jersey? What do you do?
Yeah, sure. So all products are worldwide available, all over Europe. We are in China, and we also do have a distribution partner in the US, which is Brulin and Howard Hall, who are offering our products all over the US. So most of the chemicals and the solvents and the stabilizers are available in the US. What's not yet available is the SAFECHEM system. But most of the other products are also available in the US.
That's fantastic. So thank you so much to Michael and Christian for joining us on this interview webinar, and also to the PQCW team, Barbara and Ed. We would like to thank SAFECHEM for their sponsorship of the Product Quality Cleaning Workshop. That's what allowed us to make this webinar available for free. We'll be hosting other webinars related to this in-depth content that you'll find at the workshop. Now, it was postponed due to the coronavirus pandemic, but we are looking at dates near the beginning of 2021, where we can have access to the academic labs and you can get in and do the hands-on activities. And so look for more information on the PQCW. By joining this webinar, you'll certainly receive information on that. There's a few minutes for maybe one or two questions. We received several questions on the chat. One in particular I thought was interesting. How is the use of modified alcohols different than the use of emulsion cleaning?
So do you want to?
Yeah, I can answer that. So what we typically call emulsion clean is the aqueous cleaning, and it comes a little bit to the cleaning operation. So typically, I would really recommend if you have a soil or if you have a contaminant to send it over to a machine producer and look really for the cleaning results, because we have this. If you have an oil as contaminant here, this is. I really like this. So you want to clean that with that. So you have to add a lot of soap or emulsions or whatsoever. So and to make this cleaning job done, and so you have a lot of you would have a lot of effort in monitoring the process. You would have a lot of you need to monitor the surfactants, the pH regulators. And if you have an oil, then to be cleaned off, or fat or grease, then typically solvent is a very, very good choice, because with the concept of like dissolves like, you would then end up with a very, very stable and efficient process. Whereas if you would have a salt, I could dissolve some salt here in water, but everybody knows what comes out. You would not end up well with solvents, but still, it always depends, to my mind, on the contamination. And the interesting part is when you have mixed soils. If you have oils, then I would really just recommend to go to the cleaning machine producer and observe what the cleaning results are like, and make a drawing on the energy needed, because water needs much more energy. Solvent needs less, and this is some key factors to consider, I would say. Does that answer your question? Hopefully.
We have a question that would you be able to clean things like solder fluxes, varnishes, silicones, fluorinated greases?
Yeah. Could you test it? If somebody wanted to test it, would you guys test it for us?
Sure. We would be very, very much liking to test those, because it is, we can test a lot. We have all the cleaning agents in the lab, obviously. It is still we can do it. We can do vapor degreasing, and as well, I would like to recommend to go either, if you have the possibility, to go to a demo machine of a machine producer, or to clean it if a company has a solvent or aqueous cleaning machine in the neighborhood, to see what the real cleaning result is, because it's always depending on the 4 factors of of mechanics, of temperature, of duration, and of the cleaning chemistry. So cleaning chemistry is one of the four, and all of them together are in the cleaning machine.
I will ask a short one here at the end. This will be the last question. The rest will be answered by email, either by SAFECHEM or by Barbara and Ed and myself, or all of us. So this one's very simple. What does CPS stand for? So there was the slide where we were cleaning certain pounds of soil with certain amounts of solvent. So there was CPS, and so someone would like to be reminded what that CPS stands for.
Yeah, so CPS is chemical product services. So the services which are coming then around the chemical, in our case, around the solvent. So that yeah, to have such an efficient process, besides the machine technology, you have to be able to measure the solvent. So you need a test kit to be able to see if the solvent is still in a good condition. And also as a chemical product service, we offer these stabilizers that you can bring back the solvent in a good condition. And that was the other context of that slide, that this is required for such an efficient process. And yeah, other chemical product services would then also be the lab analysis, for example.
Okay, fantastic. I think, Barbara, did you
Yeah.
have a question? Okay.
Actually, there were quite a few questions that we will answer. I had a question for the attendees. What other topics would you like to see covered in these webinars? Please drop us a note, send us an email, and we'd be happy to address them. The other question was about, there was one quick question that I think they need to answer, if we could. The question was about, are the alcohols under any kind of regulatory scrutiny? Which is a loaded question. Shall we end on that without taking 4 hours? Because, you know, everything's pretty safe if you use it correctly. Would anyone like to field that?
Okay, so there is a big difference compared to like the question that Ed raised. I mean, it is TRIC is a different word than or PERC or trans DCE NPB. It's a different word because it has a lot of characteristic. Like TRIC is categorized as carcinogen, which yeah, it may cause cancer. In not the highest category, but in the second highest one, according to GHS. And Dowclean 1601, as an example, you may see it here on this drum. You see here, this is just labeled as irritant. So it is actually, there is no exposure limits. So the MSDS of Dowclean 1601 has very much less pages, for instance, than TRIC or PERC. So this is a strong benefit for the modified alcohol cleaning. And this is actually the reason why in Europe, at least, modified alcohols are the #1 successors of chlorinated solvents, because they are just because of the substitution, of the need of substitution, and people were looking into it. The machine technology was offering it. So this is, apart from the cleaning results, the tox profile, the classification is one of the main reasons why modified alcohols have been, let's say, come up over the last 20 years so strongly in Europe.
Thank you so much. That was good. And I appreciate your time. I appreciate everyone joining in. We had a good response. And I just welcome everybody to stay in touch with us by email, on our website, and send us your topics. You can type them into the chat too here at the end of the seminar, what topics you'd like to see in the future for these webinars, and then also that you'd like for us to highlight at the workshop. So thank you, Michael. Thank you, Christian. Thank you, Barbara and Ed. And this is Darren Williams signing off. So y'all have a great rest of your day. Thank you very much.
Thank you, everyone.
Thank you.